Now, all of the isotopes of an element aren't equally abundant. When you have a hydrogen atom, almost all of the atoms of hydrogen have got just one proton in it and no neutrons. Here's heavy hydrogen, deuterium, hydrogen 2. Those were all names that we gave this. It's got one proton and one neutron. It turns out that 115 atoms of hydrogen are deuterium, or hydrogen 2, out of every million hydrogen atoms of all kinds. And that's the natural abundance of deuterium. We can express that a couple different ways. If it's 115 atoms of deuterium out of every million atoms of hydrogen of all kinds, I could take 115, right, divided by a million, and I'd get this. And I could call this the abundance of it, this fraction, the abundance. I could also express it as a percentage. If I want to write a percent means per 100. So it's kind of like multiplying something by 100 whenever you stick a percent sign on it. So I could report it like this. If I bump the decimal place over 2 places, 1, 2, it's just like I multiplied this times 100 to get this. See? Because I bumped the decimal place over 1, 2 places. So I could write the abundance either as a decimal fraction or I could write it as a percentage. Now, when you're doing problems, we're going to do some problems with abundance in a little bit. Use this one for math, the decimal form of it. Use this one to report an abundance because it's easier for people to read. So you have different purposes for reporting it in these two different forms. And don't mix them up, because if you use the percentage when you're doing math, your number here is 100 times bigger than that. So your answers are going to be off by a factor of 100. So this is what nature thinks the abundance is. This is what people like to read the abundance is.